In this video, we're going to talk about the financial aspects of purchasing a car. In other words, what does it look like in terms of calculating your monthly payment? How do you determine what's a good option for financing a vehicle? Different types of incentive programs you might have. How do you know what's a better incentive program? But ultimately, it's going to come down to calculating your monthly payment and determining how much interest you're going to owe for an auto loan. So financial agreements for cars are typically going to take on the form of what we call an annuity, specifically a fixed installment loan. So this term annuity, what does this mean? An annuity is just a sequence of equal payments made at equal lengths of time. So for instance, maybe we make a payment twice a year. We always make it at the same time twice a year. The amount of time from payment to payment is always the same, so equal lengths of time between payments, and the size of the payment is always going to be the same. So fixed installment loan means the payments are fixed and we're paying it off in installments. So when you purchase a car, they determine what you're going to owe and they break it down into payments that are always going to be the same. So what does it actually look like from the lender's standpoint? Well, the lender is going to calculate the total amount expected to be repaid, which is going to be the principal. The principal is what you're actually borrowing to buy the car, and the interest that they plan on charging you based on the terms of the loan, based on the interest rate at the time. And they're going to calculate it using the compound interest formula. So the formula we looked at in the last video that just calculates the interest, the value of the account, they're going to use that particular formula to calculate how much they're going to charge you in terms of interest and what the whole account is going to be worth to them. Now, your obligation as the borrower, of course, is to repay the loan. But it's going to be set up as equal periodic payments. So you're always going to make the same payment and you're making them at equal intervals over time in order to pay off your loan. Your particular obligation is calculated using what we're going to call the annuity formula. So again, annuity just means you're always making the same payment and you're making it over equal periods of time. So here's the formula. You can see it below. It's a little bit more involved than our other financial formulas. Honestly, the hardest part of these kind of problems is going to be typing that into your calculator. So we'll talk about what that looks like and how you can use your calculator strategically to figure out what those values are going to be. So we have the same values as our compound interest formula, but in place of A, we now have this variable PMT, which stands for payment. So the payment amount, in other words, what are you going to have to pay month to month each time you make a payment? That's what that represents. You're repaying P dollars, that's your principal, that's the original amount of the loan, N times a year. In most cases, N is going to be 12 since we typically make monthly payments, and it's going to be over T years with an annual interest rate of R. Your payment is calculated as follows. So the numerator is going to be your principal times the interest rate divided into n parts. So your interest rate, and if you're making monthly payments, it'll be divided into 12 parts. Your denominator is where it's a little more complicated. So you're going to divide by this whole value. It's going to be 1 minus the quantity, 1 plus r over n, raised to the negative nt power. Now I want you to notice that this is negative. It's going to be important that you make sure that that exponent is negative. Changing that value, leaving it as a positive number, will have a major impact on your problem. So that exponent is negative. You're going to have to make sure it's negative. But again, calculating this in your calculator, putting that into your calculator is typically the hardest part. Other than that, it's just reading the problem and identifying what values are assigned to which variables, plugging it in, and then going from there. Now, in many cases, a lender will offer multiple financing options. You may have different options for how you want to finance. There's typically a trade-off from one option to another. So one option they may give you is to finance your loan for a longer length of time. In other words, you have more time to pay it off. So the effect is typically a higher interest rate. If you're going to pay it off over a longer length of time, it's more risky to your lender, so they typically charge you a higher interest rate. The effect is lower monthly payments per payment, but the ultimate effect is that you pay more interest overall. So you may not have to pay as much month to month, but by the time you pay off the loan, you've actually paid more overall, which means you paid more interest overall. Now, if you finance it for a shorter length of time, that typically results in a lower interest rate. It's less risk to the lender because they're going to get their money faster. Because you're paying it off faster, you have to have higher monthly payments. You have to pay more month to month in order to pay off the whole loan. But because you're paying it faster and you're paying more earlier on, you end up paying less overall, which means less interest overall. So making the personal decision to go with one option or another is really up to you. If you can afford the higher monthly payments, then the effect is that you save money overall. But if you're not sure you can afford the monthly payments, then of course you finance it longer. Keep in mind, in most cases, if you finance it for a longer period of time and you have lower payments, you do have the option to pay off your loan early without any penalties. Some loans you do have penalties for prepayment, for paying something off early, but in a lot of cases you don't. So potentially you negotiate those lower payments, you make more payments more frequently, and then you still pay it off faster. So it is a trade-off going with one financing option versus another, and making the determination for what's best for you is of course a very personal decision. Now, when we look at all of your payments made together, what we're often interested in is how much interest are you paying? Why is that going to be important? Well, the principal is the same no matter what. If you're buying a car, the principal is how much the car is worth. It's how much you're willing to pay for that car. And so the principal doesn't represent what we're going to think of as a cost. Why is that? Well, if you say the car is worth $20,000, well, they're going to loan you $20,000. You're going to have to repay $20,000, but in exchange, you're getting a car that's worth $20,000. So it's a one-to-one trade. They get the money, $20,000. You get the car that's worth $20,000. So how is your lender actually making money? Well, they're making money based on the interest. Interest is something that you have to pay that you don't actually see any benefit from. So yes, you get that car that's worth $20,000, but maybe you end up paying $25,000 in total. That additional $5,000 you don't get any benefit from. That specifically benefits the lender. So we're going to think of that as a cost to you. So the question then is, how much interest are you paying? In other words, what is truly the cost of your loan? Well, interest is going to be the sum of all the monthly payments. In other words, determine what your payment is. You're making that equal payment a certain number of times. Well, how many of those payments do you make? Take all those payments and sum them up. That's going to be the total amount you pay in order to pay off your loan. Well, if you take the total amount that you paid minus where you started, minus the actual value of the car, the actual amount that you started with as part of your loan, how much you paid versus how much you started with, that's going to be the amount of interest you paid. So it's going to be, your monthly payments cover more than just the $20,000 for the car. They also cover your interest across the life of the loan. So the difference between how much you've paid and then how much you have to show for it, the value of that car, that represents the amount of interest you have to pay for your financing agreement. So let's look at a few examples, comparing your investments. How do you know which one's going to be better? Comparing incentives, different kinds of things you might have to consider when you go and buy a car. Okay, so, $20,000 car. Suppose you decide to borrow $20,000 for a new car. You can select one of the following loans, each requiring monthly payments. So installment loan A is going to be a 3-year loan at 7% interest. And then installment loan B is going to be a 5-year loan at 9% interest. So installment loan A, you have to pay it off faster, but you have a lower interest rate. Installment loan B, you have more time to pay it off, but you have a higher interest rate. So for each of these, we want to find the monthly payments and the total interest, and then we want to compare them for these two loans. In other words, how do the monthly payments compare? How do the resulting values for interest compare? So let's go one loan at a time. Let's start with loan A. Okay, so our payment, that's what we want to calculate. Let's go back and look at the formula. So it's going to be our principal, which is the amount we're financing, the amount of the loan. In this case, that's going to be $20,000. R divided by N, and then the denominator is going to be 1 minus the quantity 1 plus R over N. I want you to notice that that fraction, that's going to be the same. So that R over N is consistent from numerator to denominator. That's always going to be the same. And then the quantity 1 plus R over N is raised to the negative NT power. The denominator is significantly more complicated than the numerator. So as we type this into the calculator, we're going to focus on getting through that denominator and then use that denominator and build off of it in order to get what we need in our numerator. Okay, so what's this look like for our problem? Well, our principal is $20,000. That's what we're financing. For installment loan A, our interest rate is 7%, so 0.07. Now we're making monthly payments. So the word compounding is not here, but anytime we're talking about financing something like a car or a house, the interest is compounded. It's implicit that there is compounding involved, and it's monthly payments and monthly compounding. So we're dividing by 12. We're taking that interest rate, dividing it by 12. Okay, so that's going to be our numerator. Now again, remember that fraction, that's going to be copied and pasted into the denominator. So our denominator is going to be 1 minus the quantity 1 plus R over N, that copied and pasted fraction, and then that quantity is raised to the negative N times T power, so negative 12, and then T is going to be 3 because we have a 3-year loan. Okay, so once that's all in place, now we have to get that into the calculator. Here's what I would recommend. Here's the issue with trying to type all of that in, because with the simple interest formula and then the standard compound interest formula, it was fairly straightforward to type it all in one line. This one is going to be problematic to type in one line unless you're very, very careful with your parentheses. So I'm going to show you a workaround for how you can kind of work this in pieces, but still not have to worry about any rounding. Because as we've established, if you round in the middle of the problem, it does have a trickle-down effect to your final answer, and you may not have a final answer that's as exact as you would like. So we're going to do something kind of counterintuitive. We're actually going to start with the denominator, not the numerator, and I'll show you what to do from there. Now the denominator, you can potentially type in one line. You do the whole denominator in one line, or you do what we did before and you build off of it as you go. Okay. Now, as with the other compounding formula, the exponent, you want to go ahead and determine what that's going to be so that you can just type in a number when you're going to type in your exponent. So 12 times 3 is 36. So negative 12 times 3 is going to be negative 36. So that's going to be the value we type for our exponent when we get to that. So I want to type this whole denominator. Now the big brackets on the end, you do not need to type. Those are just there to show you that all of that is grouped in the denominator. That's all part of the denominator. But you can just start with that 1 and then just type from there. So our denominator is going to be 1 minus the quantity 1 plus 0.07 divided by 12, dividing it into 12 monthly payments. Close your parentheses, and we're raising that to the negative 36th power, so exponent button, and then negative 36. Now be careful when you type this in. If you use the subtraction button, it will not understand. It'll give you a syntax error because it doesn't understand what you're typing. The negative button is down at the very bottom of your calculator, so you're going to hit that button and then type 36. And do not forget the negative. That's the easiest part to forget. Do not forget that. And double check it. Make sure that looks the way you want. So we have 1 minus 1 plus R over N raised to the negative N times T power, which is going to be negative 36. And then I'm going to hit enter. That's going to be my denominator. And that, of course, would be a good point where you might want to write something down in order to be able to show your work. That's your fully simplified denominator. So what are we then doing? Okay, well, the goal is to take the numerator and divide by that number. Here's why I worked backwards. I worked backwards because the numerator is quite a bit simpler than the denominator. So the numerator, I can type all in one line, and then I'm just dividing by that denominator that I already have. So what I really want is all of this divided by the answer from the previous line. Well, we know how to access the answer from the previous line. It's just second and negative, and that'll pull up the answer from the previous line. So we know how to put that into a formula. So all we need now is to type that numerator. Put parentheses around it though. So I'm going to open parentheses, and then I want to type that whole numerator. Well, what is the numerator? Well, it's 20,000 times this fraction. So 20,000 times the fraction 0.07 divided by 12. All of that's my numerator. So if I put that all in parentheses, the calculator understands, treat that all as one value. Well, what are we doing with that? We're dividing by the denominator, which now has this particular value that we just found. So if I type my numerator in parentheses and then hit divide, and then use that A&S operation to bring up the answer from the previous line. So second and negative brings up that answer from the previous line. Then I have the whole expression in my calculator, no rounding involved. And so I'm going to hit enter, and there we go. That's going to be the value. So if we round to the nearest dollar, that's going to round up to 618. Make sure it makes sense. If you end up with an answer of, say, 60,000, something like that, does that make sense in the context of the problem? Well, you're taking out a $20,000 loan. Should you have $60,000 payments? Of course not. That doesn't make any sense. So something like this makes sense in the context of the problem. $600 payment, something like that makes sense if we're paying off a $20,000 loan. So try to think about the reasonableness of your answers, particularly as you work through something like this that's very calculator heavy, where it would be pretty easy to make a mistake unnecessarily. So that's going to be the value for this particular monthly payment. So you're making monthly payments of $618. Well, how many of those are you making? Well, they're monthly, so you have to make 12 of them a year. And then you have a loan of 3 years, so you're paying this much per month for 3 years. The reason I mentioned that is because the next question is, how much interest are we paying for this loan? In other words, once we pay it off, we've paid off the $20,000, but what else have we paid off? What's the additional amount involved in this situation? It's going to be the total amount we pay minus the original amount for the loan. The difference between the two is always what we think of as interest. So I'm making $618 payments 12 times a year for 3 years. So if I take my payment amount and multiply it by 12, well, that's how much I pay per year. But if I multiply it by 3, then that's distributing those over 3 years. So what's that going to come out to? Well, so we have 618 times 12 times 3. That's going to be the total amount you pay across the life of the loan. Notice it's more than $20,000. That makes sense because you're paying more than $20,000. What you're paying additionally is the interest for the loan. So if you take the total payments and subtract $20,000 from that, then that represents the actual cost of your loan. That represents the interest. So in this case, for this particular loan, under these particular terms, you're going to pay $2,248 in interest. So $618 per month for a total of $2,248 of interest across the life of the loan. So you can put that down at the bottom for a 3-year loan at 7%, $618 per month, $2,248 in interest. Okay, now we have another financing option. We want to see what the effect is. So the additional option means we could finance it longer, but in order to finance it longer, they're going to charge us a higher interest rate. So by financing it longer, we get the interest payment down, but there's a trickle-down effect to the actual interest we pay. We may be paying less month to month, but overall we'll be paying more. So what's the actual comparison going to be? Well, let's do the same calculations, but let's do it for the second option. So same formula. What's going to be consistent from situation to situation? Well, the principal is going to be the same. Okay, we're compounding the same way because we're still making monthly payments in either situation. So the value for N is going to be the same as well. But what's changing is the length of time and the interest rate. So P and N are going to be the same, R and T are going to change. So our payment is going to be $20,000 times R over N. Well, now R is 9%, so 0.09 divided into 12 parts. So that's going to be our numerator. And then our denominator is going to be 1 minus the quantity, 1 plus R over N. Again, notice copy and paste for that fraction. And then our exponent is going to be negative N times T, so negative 12. And then this is a 5-year loan, so T is going to be 5. So let's type that one in as well. Again, do the denominator first, start there, and then add in the numerator and use that A and S operation. Now the exponent here, 12 times 5 is going to be 60. So negative 12 times 5 is going to be negative 60. So our denominator is going to be 1 minus the quantity, 1 plus 0.09 divided by 12, close your parentheses, and we're raising that to the negative 60th power. So up arrow, and then negative 60. Again, make sure you use the negative button and not the subtract button. If you use the subtract button, it'll give you a syntax error and it'll kick you back out. Okay, so that's going to be our denominator. All of that. What you'll find is every single time you do one of these, your denominator should be a decimal that's less than 1. If it's something greater than 1, or if it's negative, something like that, that means you made a mistake. It means you need to go back and check your numbers. You need to type it in again, making sure that you have parentheses where you're supposed to have parentheses. Okay, so that's going to be our denominator. Now remember, we need to build in the numerator. So it's going to be the whole numerator divided by this answer. So I'm going to put parentheses around my numerator, type it in. So 20,000 times the fraction 0.09 divided by 12, or not that, 0, delete 12, there we go. And then close the parentheses. That's going to be the whole numerator. We're taking all of that and we're dividing it by the answer in the previous line. So divide by that denominator, represented now as the previous line in the calculator. So second and negative brings up the answer from the previous line, and then that's going to give me the whole expression for my payment. So hit enter, and there we go. So to the nearest dollar, that's going to be $415. So roughly speaking, that's going to be our monthly payment to the nearest dollar. So what's the effect? Well, we went from a $618 payment per month to only $415 per month. But we're making this lower payment over a longer period of time. So we save about $200 per month, but we have to continue making payments for an additional 2 years that we didn't have to make them before. So the ultimate trade-off is going to be an interest. We want to know for this loan, how much is the interest going to be? Well, this is our payment per month, 12 times a year, and in this case for 5 years. So the total amount we pay for this particular loan is going to be $415 times 12, that's going to be per year, times the 5 years over which we make these payments. And that's going to be the total amount. So once we pay off the loan, this is the total amount we've paid. Well, we're paying off a loan of $20,000. So minus $20,000, the difference between the two is the amount of interest we're paying. It's everything that's attached to this loan above and beyond what the loan was originally worth. So $4,900 is going to be our interest there. And so we can add that in at the bottom as well. $415 per month, but overall we have to pay $4,900 in interest. So again, it's a trade-off. The first option requires you having more in month to month. If you don't have all of that month to month, then you may have to go with the second option. But the second option means you pay more overall. You may pay less month to month, but because you're making payments for a longer period of time, you end up paying more interest overall. So again, it's a personal decision what kind of financing options you go with, but keep in mind there is a trade-off regardless of which direction you go. Okay, let's look at another example. What about the determination of new versus used? What's the trade-off for buying a new car versus a used car? Well, there's a lot of differences. New cars, for instance, may get better gas mileage. They may still have a warranty, but of course, they're going to cost substantially more than buying a used car. So that additional money you're not making in payments may be able to go towards car repairs and towards gas, those kinds of things. So there is, of course, a trade-off going new versus used, just as there's a trade-off with financing it for a longer or a shorter period of time. And ultimately, those decisions are personal. We just want to look at the math comparing two situations. So suppose you're thinking about buying a car. You've narrowed it down to two options, new or used. So the new car you're interested in is $28,000. It can be financed with a 4-year loan at 6.12% interest. The used car you're looking at is $16,000. It can also be financed with a 4-year loan, but it's at 6.86% interest. So what you'll find in general is that new cars are financed lower than used cars. In general, the standard interest rate for a used car is going to be more than it is for a corresponding new car. And again, we want to compare the difference in monthly payments. What's going to be saved overall from one situation to another. Now, why can we compare it just apples to apples? We can compare it because it's the same length of time. So if we have two loans that are covered over the same length of time, paid off over the same length of time, then we're making the same number of payments from one loan to another. So the net difference, the total difference overall, is going to be actual savings overall, because we're not talking about different lengths of time. We're making the same number of payments in each situation. So savings from month to month represents savings overall. So let's calculate the payment for the new car. So the principal, the amount for the loan, is going to be $28,000. Our interest rate is 6.12%, so 0.0612. And again, we're making monthly payments. So we're dividing that into 12 parts. Then our denominator is going to be 1 minus the quantity, 1 plus, copy and paste your fraction, 0.0612 divided by 12, raised to the negative nt power. So n is 12, t is 4 years, so 4. And again, don't forget that negative. So start with your denominator. We know that exponent is going to be negative 48. So when you get to the exponent, you're going to type negative 48. So 1 minus the quantity, 1 plus 0.0612, divided into 12 parts, close your parentheses, and that's being raised to the negative 48 power. So that's going to be our denominator. Again, it should be a number that's less than 1, positive number, but less than 1. Okay, that's our denominator. So now we need our numerator and then divided by that value. So in parentheses, our numerator is 28,000 times the fraction 0.0612 divided by 12. All of that is our numerator. And then we're dividing by the answer in the previous line. So second and negative brings up that answer. And then we hit enter. So to the nearest dollar, that's going to be $659. That's going to be the payment from month to month to buy this particular car under these particular financing terms. Now, what if we go with the used car instead? Okay. So now it's going to be $16,000 as our principal. That's the amount of the loan. Our interest rate has gone up a little bit though. So 0.0686 divided into 12 parts for our monthly payments. And then our denominator, notice the denominator, the only thing that changes is that fraction that's then copied and pasted. Notice that the exponent didn't change though, because we're still doing monthly payments and we're still keeping the loan for the same 4-year length of time. So let's see what this one is going to be. So start with the denominator, 1 minus the quantity, 1 plus 0.0686 divided by 12. And then all of that is being raised to the negative 48 power. So raised to the negative 48 power. There's our denominator. Slight difference from the previous one. The denominator didn't change all that much because the interest rate didn't change all that much. So now we need the numerator divided by this particular number. So in parentheses, 16,000 times the fraction 0.0686 divided by 12. All of that's our numerator. And then we're dividing by that number representing the denominator. So divided by the answer from the previous line. And that's going to be $382 per month. So now we want to compare the difference. How much is saved month to month? How much is saved overall? Well, from month to month, we go from a $659 payment for our new car to a $382 payment for our used car. So the difference between those two is a savings of $277 per month. Keep in mind, some of that is attributed to the fact that we now are paying $12,000 less, but some of it is also attributed to interest. We're paying $12,000 less overall just based on principal. But for the second option, because we're applying our interest rate to a smaller principal, we're also saving money in terms of interest. So $277 is saved per month, same amount saved per month, and we're saving that 12 times a year for 4 years. So $277 per month times 12, since there's 12 monthly payments per year, times 4, since the length of the loans is going to be 4 years. And that's going to be our savings overall. So how much is actually saved in interest? Well, we know the difference in principal is $12,000. So a portion of this savings is the $12,000 based on buying used versus new. So if we were to subtract the $12,000, this is the remaining amount. That represents interest. Anything not associated with principal represents some type of change in interest. So in this case, that would be the amount of interest that's saved from one situation to another. So notice that even though the used loan has a higher interest rate than the new loan, because that interest rate is being applied to a lower amount of principal, the effect is that we have less interest charged for that second option overall. But again, it's a trade-off, buying new, buying used, just like it's a trade-off financing for different lengths of time. It's a personal choice what you go with. Do you have $659 per month or do you have $382 per month? Ultimately, those are the kinds of decisions you have to make. Now let's look at one final situation. What happens when you go at the end of the year to buy a car, because you know that's when they're going to cut you a deal? Why do they do that? Well, they've got to get all the cars off the lot so they don't have to pay taxes on them. Any leftover inventory they have to pay taxes on at the end of the year. So they will cut you a deal in order to get all those cars off the lot. What if there are different buying incentives though? How do you know which incentive actually makes more sense? Just like financing options, you may be offered different kinds of incentives. So suppose you're buying a car for $35,000, which includes all your taxes and your license fees. Now you saved $10,000 for a down payment. What does that mean? Well, remember, the down payment is what you pay up front. So once you sit there, you sign on the dotted line, you're going to give them $10,000 up front, which means you now don't have to finance the whole $35,000. You pay the $10,000 today, so you're only being loaned whatever portion of the value is left over after the down payment is made. Okay, so you're going to make that down payment no matter what. Now, once that's made, you're financing the rest, but the dealer is offering you two different incentives. So incentive A, you're going to take an additional $5,000 off above and beyond your down payment, and then you're going to follow with a 5-year loan at 7.34% interest. So you're only financing $10,000, $5,000, $15,000 less than the original value of the vehicle. Now incentive B, there is no cash rebate, so you're taking off the down payment, but you're not taking off that additional $5,000. But instead, you get free financing, which means no interest over the 5 years. In other words, you're not having to apply an interest rate at all. All you're doing is just making sure you pay off the actual value of the vehicle, no interest involved. Okay, so what's going to be the better option? That's the question. What's the difference in monthly payments overall? And then based on that, what's the better offer and how much would you actually save based on taking the better offer? Okay, so let's analyze what happens in incentive A. Now, regardless, remember we're making that $10,000 down payment. So rather than actually financing $35,000, we're taking that $10,000 off, and that particular amount that's left over is what we're then financing. Now for incentive A, we also get to take an additional $5,000 off. So they're giving us the $5,000. We've paid the $10,000 ourselves, so we're subtracting a total of $15,000 from the original value of $35,000. So that means the amount being financed is going to be $20,000. That's the actual amount we're getting a loan for. So this was paid from our money, this was paid by the dealer, this is the amount we have to pay off in terms of a loan. So what is our payment going to be if we're financing $20,000 based on this particular loan? So monthly payments for 5 years at 7.34% interest. Well, our principal is going to be $20,000. R divided by N, 0.0734 divided by 12. And then our denominator is 1 minus the quantity, 1 plus 0.0734 divided by 12. And then N is 12, and T is going to be 5 in this case. So that means our exponent is going to be negative 60. So let's calculate that payment. Start with your denominator. 1 minus 1 plus 0.0734 divided by 12, and then we're raising it to the negative 60th power, so raised to the negative 60th power. Okay, there's our denominator. So then we want to type the numerator, $20,000 times 0.0734 divided by 12. Close your parentheses, there's your numerator, divided by the answer from the previous line representing the denominator. And that comes out to the nearest dollar, $399. So that's going to be the monthly payment. Now what does that represent? That represents paying off the $20,000 plus whatever additional amount is then attributed to interest based on that 7.34% rate applied over 5 years of time. Okay, so $399 per month. We could go ahead and determine how much we're going to pay in total as well. So we're paying $399 per month. We're paying that for 12 months per year, and we're paying that for 5 years. So we're going to pay a total of $23,940 associated specifically with the financing. So remember, we had to pay the additional $10,000 up front, but that is not subject to any interest because it's paid up front. This particular amount is what's paid in association with the financing of the $20,000. So how much of that represents interest? Well, if we take off the $20,000, then $3,940 represents the amount of interest we're charged based on these terms and based on financing the remaining $20,000. Now, what happens for incentive B? Let's look at that. So incentive B, remember, there's no cash rebate, which means that extra $5,000, we don't get that. There is no extra $5,000. But we get free financing over 5 years. That means we don't actually accrue any interest on this loan. Now, we still get to make the $10,000 down payment. So we're still doing that. So $35,000 minus 10 means $25,000 is what we're being loaned. But because there's no interest, we don't actually have to use the payment formula. All we're doing is taking the $25,000 that we've been loaned and just paying it off month to month over 5 years. Well, if we're making monthly payments over 5 years, how many payments is that in total? Well, it's going to be 60 payments. So what happens with incentive B is all we're doing, because there's no interest, because it's free financing, all we're doing is taking that loaned amount and paying it off over 60 equal monthly payments. But because there's no interest rate, none of this is involved. It's just take the amount, divide it into 60 equal parts, and then pay it off that way. So $25,000, and we're dividing that into 60 equal monthly payments, no interest involved, so just paying off the $25,000. And rounding, that's going to be $417 per month. So $399 for option A $417 for option B. Again, it's apples to apples in terms of the comparison because we're paying for the same length of time. We're paying a 5-year loan, a 5-year loan. One requires interest, one doesn't require interest. But because we're making the same number of payments, it is truly apples to apples in the sense that whichever one we save money on month to month, we save money on overall. So the difference per month with option A, which is the lower monthly payment, is going to be $18. So even though we do have to pay interest, the effect of taking off that $5,000 was enough to get us a lower monthly payment than if we just had free financing. So if we're saving $18 per month, well, that's saved every month, so 12 months out of the year for 5 years. So $18 per month times 12 months in the year times the 5 years over which we save that, for a total of $1,080. So that's going to be the amount we save overall. So in this situation, it's not a weigh it and determine the better option. In this case, the better option is the one that's lower monthly payments. It's the same car, you're making the same down payment, so that's not going to change. With option A though, you end up with a better monthly payment, which means you save money overall. So these are a few things to consider when you're looking at purchasing a car. Weigh your options in terms of financing, weigh your options in terms of incentive, buying a new car versus a used car. There's always trade-offs one direction versus the other. These are different things to consider, but again, ultimately a lot of it comes down to personal choice and just what feels best for you at the time.